Hi, everybody. Dermot O'Shea here, and I'm the host of the Antenna podcast. And today I'm delighted to have our guest, Minya Gavrilovic. Minya, would you like to introduce yourself and maybe give us a background of where you are today and what you do?
Yeah. Hi, I'm Minya Gavrilovic. I am leading the antenna and filter business at Andrew, which is part of a greater Amphenol business. I'm based in Ottawa, Canada. I've been in antennas my whole life and look forward to chatting about it.
Great. Okay, well, sure, maybe tell us more about that, your whole life. Like, tell us, how did you get started? What piqued your interest first in antennas?
Well, I found my way into antennas by the company I chose to work for, which was a satellite company, a space-based satellite company. I had done a PhD in electromagnetics, and specifically in finite element methods and optimizations, the things that we use in like HFSS or some of CST today. That was my expertise. But the company I worked for was doing design of spacecraft antennas, and that's where I cut my teeth as an antenna engineer, starting I think in the year 2000. Um,
Okay.
so um, that's how I got into the field. Um, and I worked as an engineer for 7 or 8 years in that field, which was, highly enjoyable.
And where did you do your PhD?
I was also in Montreal. I'm Canadian based, so it was McGill University, which
Okay.
is a
Yeah.
fairly well known university in Canada. So yes,
Yes, I've passed by some of those buildings when you're in downtown Montreal, right?
absolutely, it's a beautiful campus there. So it's great downtown campus, but still old and very renowned. So the founder of our lab there was the founder of finite elements for electromagnetic simulation, Dr. Peter Sylvester. So that was the foundation for everything we use in HFSS today. So yeah, no, I came from that lab, so it was a great environment.
Super. And so you got right into actually working on design when you started working for this satellite company.
I did, yes.
What kind of antennas were you involved with designing?
So some were communication antennas, reflectors, and feeds, but that wasn't my specialty. I focus more on the radar application side, so either radar antennas or synthetic aperture radar for remote sensing applications, for mapping, and so made those all array antenna theory and design for me in the early going. The other side of the business, which was more communication, reflector based, shaped reflectors, multi feed with physical optic simulation, and that was not something that I was heavily involved in. I was more of on the radar and array side.
Yeah, we haven't actually discussed radar antennas yet on the podcast, and it's not something I know about myself. Maybe you could give us a quick intro to radar antennas. What's different about them? What type of designs do you use?
Again, in radar antennas, it depends. And I said radar, they're mostly synthetic aperture radar, where now the bandwidth is not a traditionally big focus as it is in communications, where we need a big fractional bandwidth. So your bandwidth is not as much a limitation, but power is. So power is an issue, and some problems such as um, in terms of like passive intermodulation that we may have in communication systems, you don't have in radar. So that is certainly a relaxed factor. But once we get into array theory, similar to that we have in communications, things that run into challenges, scanning or intense scanning that causes scan blindness. These are things that can happen in radar that need to be taken care of. So I'd say these are some of the challenges, of course, in radar. So
And are you designing like for distance or gain, or like what are you kind of aiming to achieve when you're sitting down to think about a radar antenna?
again, you are all those things. Efficiency is important, and I'm going to talk about efficiency later on.
Okay.
But again, scanning is a big part of radar, right? And whether it's azimuth scanning or elevation scanning and how you do it is a big piece of the puzzle there. So details of array technology is important, mutual coupling between elements, um, isolation, these type of things are important in the design process.
And so yeah, so where did you did 7 years in that company? Where did you go from there?
Yeah, I went from there into the telecom industry where I've been pretty much ever since. And I worked for a small company called 10XE Wireless in Ottawa, which was a fantastic experience. I joined as a product manager there, where I got exposed to the customer and the business side. So I actually stopped designing and I was speccing out products and evangelizing new technologies to customers. So that was a wonderful experience and one of my favorite jobs in terms of being able to talk to customers and learn what they need to apply it in practice. So that's where I spent a few years. I went back to the space industry in the Canadian Space Agency for a couple of years, but came back to that company as head of engineering later on. So I went back to a company that was rebranded as another company called CCI. It was the same company. But I was the head of engineering at that time, which was, a lovely time where we did a lot of amazing things with my team there.
Yeah, so you had it's always great for an antenna engineer to get that more customer facing experience like you did with the product management, because then you understand and feel more of, what it is the customer's trying to achieve when you're doing antenna design.
Absolutely. And, it's a fine balance, through this experience and I try to train my product managers or engineers when they're communicating with customers is being able to lead them to a path of something you can realize, right? Because you have a lot of different customers. Some customers are very educated. They can squeeze you to the last tenth of a dB. You have some customers who don't really understand, and the laws of physics are sometimes a challenge because they just don't understand something's possible. But it's our job as business people in the antenna field to bring them to something that's practical that works for them, and that's the most exciting part of my job. It's the most exciting part of my job today, to be honest.
Great
Um,
stuff. Yeah. And the price, right? The price is always important. Do
absolutely,
it
and
a cost efficient basis.
absolutely, like there's cost is we're in a very competitive field. Cost is huge. Designing for cost. Um, Innovation is big, right? Pricing your technology that's differentiated among others is important because that can come with a bigger price point. And I've used this term before in interviews. I used it recently in an Andrew presentation that I've used often is that you need to be technologically courageous in our field. And we're able to do that in antennas. Push the boundaries a little bit, do something that others won't, and they're not in their comfort zone. That can gain you differentiation, potentially more margin, or secure a potential market and help you on the other side of the cost equation. So innovation is a big part of my strategy always, and it's always has been no matter what company I've been with.
Great stuff. And so so you were at the CCS, you said, is it, as the
CCI, and I was head of engineering. And then following that, I went to a company called Galtronics,
oh yeah,
where I was the chief technology officer and was also in charge of engineering for two different businesses. One was a infrastructure telecom business, similar to what I do today at Andrew and as CCI. And I've started a new business or group or R&D center in Ottawa. And there was another business line that did antennas for Wi-Fi, um, more embedded antennas into CPEs, into gateways. That was a different business as well. And I was the CTO for both of those. Through my time there, by consequence, I was asked to become president of that company as well. So that was my exposure into profit and loss and owning the entire business, and that was a great learning experience because now I was the president and responsible from top to bottom, sales to cost to production to everything. So that was a great time, and that's I was at Galtronics I think for 6 years doing that overall. So.
very good. And how did you end up in Andrew then?
So I came to Amphenol, the companies, to integrate. There was a nice challenge. They had three companies globally, one in the US or two in the US, one in France. And they wanted someone to combine the technologies of three companies and the customer base to leverage that to make it work more efficiently. And that was called Amphenol Antenna Solutions. That's why I joined Amphenol. Um, and we had great times. and there was a tremendous experience. And Amphenol is a fantastic company, really entrepreneurial company that focuses on the right things, and its stock price has reflected that. Um, but about a year and a bit into my time there, they announced the purchase of our largest competitor, which was Andrew. And among that was the antenna business, which was much larger than our Amphenol Antenna Solutions business. So I had the opportunity to take over as the general manager of the antenna filters business. And we amalgamated the Amphenol Antenna Solutions business into one big business so that we combined them all globally. So I spent the last year kind of consolidating the product portfolio in that. And we're still in the midst of doing that. We have some duplicate products that we're trying to clean up, but that was more or less what was happening. So now at Andrew, I run the antenna business. It's still part of Amphenol, but as Andrew.
But is that mainly telecom base station antenna solutions?
Yeah, yeah. And
Yeah.
we do more than just base station. I'm kind of rebranding the name as well, but traditionally we've called it the BSA, or base station antenna business and filter business. We do other ones. We do small cell. We do like street level small cell. We do venue antennas for DAS applications. And we're looking at different opportunities as well. So we are more than just a base station antenna company, although we are probably the prominent Western name in base station antennas everywhere. So we have probably, again, one of the largest companies in the world in this space.
Oh yeah, like I've always looked at Amphenol, even before the Andrew acquisition, as the largest antenna company.
Yeah.
I know not all the businesses antennas, like a lot of connectors and cables and stuff as well, but definitely the gold standard when it comes to an antenna business anyway.
Yep.
Yeah, so it's been a phenomenal journey, as you said, reflected in the stock price. I know some people that left and work in other antenna companies that regretted it just based on
Yeah.
the price alone, right?
Yeah.
Um, but yeah, that's great. And so you've seen so many use cases then, and so many different types of antennas. Like what's your kind of favorite or project that you're most proud of, or something, or an interesting like use case or application you can tell us about that you were involved in, maybe?
Yeah. I, there's a couple, if I thought of the coolest application, it would be an interesting radar application I did way back in the space, in the satellite company I worked for. Is actually a step out opportunity for doing a, a radar application that penetrated water from a airship, like a blimp, essentially. So it was a very, very large aperture antenna. We created a demonstrator at L band just to show the technology, and it was 5 by 3 meters at that size at L band, and it was going to be 3 times larger in the real applications due to the frequency. And it was really for monitoring, you know, objects, let's say, that are underwater. So it needed to be low frequency to penetrate underwater, and it had to be ultra light. And, how did you make an ultra light antenna array, which was extremely challenging? One would think it's easy, but it's got to be able to fold into a box and deploy. A lot of mechanical challenges, but the RF challenges were there too. How do you maintain alignment between dipoles? How do you connect things between layers of this multi-layer array? Things that seem trivial, like, oh, we'll do the feed network with coplanar waveguide. And coplanar waveguide gets very fun when there's not a lot of PCB. And if you have only a couple of mils of PCB, it's effectively an airline with coplanar waveguide that really likes to radiate. So a lot of interesting challenges there. I thought that was a really cool project.
And did it end up becoming a product that you would put on an aircraft or as it hovered
Honestly,
over the ocean?
Honestly, I don't know. There was two phases of the project. I'd left the company, so I lost visibility where it ended up. We had the second phase that we had won, and then I left, and I had gone to the telecom side. But I hope it became something because it was very interesting.
Yeah.
In terms of projects that were successful, I at CCI, that same instance of 10XC, during the first LTE or 4G build, we were responsible for delivering one of the first. We used to call it hexport antennas. One array of dual pole low band elements, and then two arrays for 4x4 MIMO of mid band elements. 2 gigahertz PCS band. At the time, getting good patterns out of that was a big deal. Today, that seems really simple compared to what we have to do now. But we had done that in a record amount of time through my business in Ottawa, and we developed a product, got into a customer's hands within 3-4 months, and it was just lightning quick. And my team, some of which are still at that company, phenomenal, probably one of the best engineers, she still works there, that I'm really proud of. And the magic of that was getting the performance that the customer needed in a practical and pragmatic way. And one of the things that I'm sure you'll agree with is the challenge with RF engineers is the ability for them to be able to even tell themselves, put down the pencil, you've done enough, right? Because perfection is hard, and
Yeah.
they keep going. They'll keep optimizing. It's never good enough. But the ability to say it's good enough, this is the time to stop, is magical.
Yeah.
Converging to the right solution also is magical as well. But that ability to stop and know something's practical so you can get into the customer's hands, that's something that's fantastic. A lot of pride in that. So that just the scope of what that did and deployment and sales it generated, I think was very exciting to me, because as much as I'm a technologist, I'm in it for the business. I want it to be successful. I want to be able to see it on a cell phone tower when I drive by. So it was a big
Yeah.
success.
Yeah, everybody in the industry loves that. I know engineers, they love to work on projects that go ahead and just get into production, and they can see the real life use case of it and tell themselves, I did the antenna for that, even if it's something
Yeah.
simple like going on a vending machine or something. It's
Yeah.
and you see it in the airport, it's satisfaction. Um, but yeah, I agree with that like Steve Jobs always said that, if you wait to launch the perfect product, you'll never launch a product.
That's
So
right.
you got to market test it first and let the customer put their hands in it, because invariably they'll probably change something along the way anyway, and a lot of the time it might not even go ahead. Right? How
Yeah.
many projects do we work on that don't actually go ahead in the
Absolutely.
first place? So but yeah, and and then related to that, Minya, we always try and jump into some technical uh aspects on the podcast here. We asked people just to give us a quick deep dive into maybe a technical topic or word or subject or aspect of antenna engineering. So yeah, I'll hand it over to you. Let us know what you have for us today.
Yeah. I thought, the interesting word that's used a lot in my business is efficiency. It can mean a lot of things in a different world. It can mean, if you're just, an omni antenna on a CPE, it could mean something very different than what it means in our world. In the pure world of antennas, aperture efficiency means something. In our world, it means really two things, right? So in our world, it means, I would define it as the best way to achieve gain with a very low loss. The difference between directivity and gain is efficiency in one aspect. So our antennas at Andrew, we have some options that are very, very highly efficient, that have very, very low loss, that achieve with a cableless design and still has phase shifting capability, tilting the beams, and incredibly low loss. So obviously not too much dielectric in there to be able to achieve this. And that's one aspect of efficiency, and just having that. And the reason that is important is, again, for two aspects. Some would say generating higher gain to get more coverage for a cell site. The other is really that's gaining traction, especially in Europe. I think it's coming to USA, is the ability now to turn down radio power to get the same EIRP you had before. So now I can get the same footprint by using less DC power. I think it's been driven largely by the green movement in Europe, which is
Okay.
phenomenal. I think it's a great thing. I think with the advance and the consumption of energy that AI is going to bring through data centers, the pressure is going to put on the grid. I think on the cell phone, on the telecom network side, we're going to see pressure on power consumption in our networks in a big way. So
Mm.
power will be at a premium. So efficient antennas in that way are important. The other side to efficiency that's really important to us is basically radiation efficiency. And again, this one's tricky. I define this one as getting as much of the signal in the area you want as possible. So to us, in our world, everything within a given sector, if I'm trying to get it between plus or minus 60 degrees in azimuth, looking top down, I'm trying to get as much signal in there with as little signal in the adjacent sectors, because if it's splashing into the left and the right or too far, it's creating adjacent sector interference and just reducing my throughput and lowering my signal to noise ratio overall and ruining the performance. So I want, really good signal to noise ratio. And how do I achieve it with a really radiation efficient antenna? And that's something that we focus on a lot at Andrew, that we're making sure that in a three-dimensional way, we're controlling antenna patterns to radiate in the right sector. So different type of way to look at efficiency. I thought it was kind of cute that, there's two different ways to look at this efficiency. And again, probably different than someone else would use it, but it is a terminology that's used a lot in the different types of antenna fields for sure.
Yeah, no, it's great explanation, and it's great to have that as a reference, because we know a lot of customers ask us about antenna efficiency, and they really all they know about it is I should select the antenna that states the highest efficiency, right? So
Right.
yeah, and not understanding what it means and how it can be different for each use case is important. You mentioned something interesting there about the base stations and the power demands. I've seen also space demands real estate, like, has become incredibly challenging for telecom base station antennas. So, how have you seen that come up as a challenge, and how is that something that you have to live with as well every day, and how do you design around that?
It is. That's, size is always a premium. We're trying to make antennas as small as possible. Trying to put as many arrays, when you see a base station antenna on a tower with a lot of cables, like I say, every connector is an independent antenna. We co-locate things with dual polarization, typically plus or minus 45-degree linear in our field. So that's a dual pole antenna. So it's two antennas, but then we have different bands. We have ones stacked on top of each other or overlaid. We have antenna elements that are transparent, that ghost. We call them ghosting elements, that are transparent to other elements, so they can radiate through them from different brands without corrupting the patterns. We do some really interesting things, and that's also where Andrew is unique. Is we have an ability to do frequency selective surfaces on our antennas that are transparent for some bands but are reflective for others. So we could have a 900 megahertz antenna that's full length, maybe 2.5 meters, but then someone could put a 3.5 gigahertz massive MIMO integrated antenna radio behind our antenna, attach it to the antenna, and radiate right through. So it'll
Hmm.
radiate right through, but we still have not lost any of the gain of the full length antenna, because it's transparent to that 3.5 gigahertz. So that's a clever way. And that's really the reason for that, is reducing the overall footprint of the package.
Okay.
Because we're trying to get everything really close together and not create the clutter on the tower. So that's a big application for that.
And so in that example, the 900 megahertz antenna is, so when it's coming in at the higher frequency, it doesn't reflect, it doesn't refract, it does that particular, it just sees that particular, doesn't see that particular material essentially. And
Correct. So at the higher frequency, it's seeing right through it. At the lower frequency, it's, truly, the reflector is it's that frequency selective surface becomes a reflector that's using it as an array. But as the higher frequency, it sees right through it. So that's, our mosaic line that we brand. And again, that this is one of the real kind of early innovations that in this space that Andrew did a few years ago. So it's quite
yeah,
successful.
yeah, it was interesting. We had a guest on recently that remarked at how much innovation and engineering and hard work goes into antenna design, and was wondering, like, are we really properly rewarded for all that? So but
Never enough.
I know, yeah. But look, I think it's a rewarding, field to be working in. Like,
Yeah.
how many engineers do you have in Amphenol overall? There must
Um,
be
we have we
thousands,
have we
right?
have hundreds of engineers in Andrew. We have a big team globally. Again, we have engineers in USA, France, Italy, China, India, primarily. So we have a fairly large teams. Again, we're a global company. We serve many markets.
Right.
It's not just a U.S. company. We're very international, very present in Europe. That's a key area for us, but also internationally in Middle East, Asia, Africa, so everywhere.
And what attributes do you look for in a person, if you when you're looking for them to be a successful antenna engineer?
Ownership, understanding that they own the results of the product. Um, and it depends what level, but again, for the senior people, I see the ability to converge to a solution. I always said, you've seen it, many engineers end up in the lab. You can do as much simulation as you want, and that's going to even increase with AI. But at the end of the day, when you build it, how is it going to match? You do that in the lab, and there's tuning involved. And you'd see the senior engineers, I say, if you see a junior engineer, it's like, this is the convergence slowly, but the senior one, it gets really close quick, right? So they can get to the solution very quickly. I look for that. I look for the closers, can they get to a solution and say it's good enough? That's the rarest trait. There's absolutely
Okay.
rarest trait. And the one that doesn't always, coincide with the closer is the innovator, right? So the innovator, I hire, we're a field of a lot of graduate degrees, a lot of PhDs. I've hired many PhDs. Some are amazing, some are not as amazing. What I look for is someone not chasing every publication. There's a lot of people who get obsessed in looking at what others do and, what did that person do? What did that person do? Was it written in the paper? Then there's the ones who actually come up, from, ground up theory and saying, how can I be creative to find the solution? Some of the most creative ideas I've seen have come out from their own minds, not from a paper. So I kind of look at creativity in a big way. I think we work in a very creative field. That's one of the reasons I love it, because of the creativity. So that's another important aspect for me, from at least both the RF side and mechanical side. Our products, as you know, are very physical. So implementation is a big deal. So mechanical engineering has its own, tremendous innovations as well, as much as the RF side, the electrical side. So yeah, creativity is a big deal for me.
Yeah, great answer. Yeah, I'd agree with everything you said there, 100%. And then we get asked sometimes, any advice for anybody that, has, you make it sound fantastic. And if anybody wants to check out, there's so many antennas that you'll see online from Andrew and Amphenol. How would you tell somebody to get started if they were interested in this business?
Okay, I think an easier entry is if you have at least some graduate degree. I think that would attract to companies. You don't need a PhD. A master's is probably enough, to get some specialization in it. And getting your hands dirty as much as possible. Everybody can simulate, and simulating is just going to get more and more automated, to be honest, with AI. And the magic is going to be, what can you do with that simulation now? What can you do with that creativity? Because putting everything together and coming up with a customer solution is not so obvious. So I think if you're in an industry that you can find something that's close to an application as a first step, that could be a good entry into the point, because you'll get more excited about it. The other one as a recommendation is get experience in test engineering. There are so many people that are great at simulating. They don't understand that, again, someone measures 14.18 dB return loss, and it's not 14.17. I go, if I can't measure it, it's meaningless, right? I'm not, if you're doing double digit precision for something that, is a tenth of a dB, it's kind of silly, right? So understanding the practical limitations of test and measurement are important. And I'm continuously shocked by how many of engineers we have that don't have that capability. And I was lucky in the satellite industry and the space industry that there was a big focus on that. And I kind of went through the school of learning test and measurement and appreciating that, to understand how accuracy plays in to the whole thing. So I think that's a great place to learn as well.
Yeah, in fairness to the universities these days, though, I do think they put more of an emphasis in their antenna
I
courses on
do.
also building and testing and not just the theory. So
Right.
it's definitely getting better.
Yeah.
Yeah,
And then now, they have tools that we didn't have, many years ago, 3D printing. It's easy to implement these things at a better cost, and get it out and test and measure it too. So
great. Well, listen, that was fantastic information there. We're delighted to finally have somebody represent the machine of antennas, Amphenol. So it's been great. Thanks, Minya.
yeah,
I'm Dermot O'Shea, host of the Antenna Podcast. And Minya, thanks very much. It's been a pleasure.
great. Thanks, Dermot.